Hello. In this video I want to think through a markedly more difficult example than that which was covered in the previous video introducing previous introductory video on how to solve trig equations. The reason I say it's markedly more difficult is because we have compression here and we also have a phase shift, right? So solving something like this, an equation like this, is much different than solving something more simple, say like cos theta equals 1/2, right? Because we picture the graph, it's all fine. Let's say it's the same interval. We're going to get that's arc cos. We're going to get theta equals arc cos 1/2, and so on. And there's no shift in the graph. There's no compression or anything like that. In this case, there is. There's clearly a phase shift, and there's clearly compression. And in this case, just to get all of our solutions for this equation, in solving this equation, we need to manipulate the interval, what I would describe as manipulating the interval. And what that means and why it works will hopefully become more clear in a few minutes. But so as I mentioned in the first video, there are a number of different ways on how to solve trig equations, including graphical methods using symmetry, etc. But I prefer algebra. That's just what my preference. So I'm going to solve this algebraically and just basically work through the steps. So in this case, we're given 2 cos of 4 times x over 2 minus 22. All of that's closed off in brackets, so plus 6. And then all of this on the left-hand side is set to equal 7, okay? So, I mean, how do we go about this? Well, the first thing we can do is we just want to start cleaning this up a little bit, the left-hand side. So how do we do that? Well, we can use, it stands out, we can use the distributive property here with this 4. We distribute across the bracket, that internal bracket. So let's do that, and it should start to get, we should be able to start cleaning things up a bit after having done that. So we're going to get 2 cos and 4 times x over 2. I'll just write it all out to make it explicit, right? 4 times x over 2, that's 4x over 2. 4 times negative 22, that's going to be negative 88. We can close the brackets off at this point, and we still have our 6, and all of that again is still set to equal 7. And so we can still simplify this actually, can't we? Because 4 divided by 2 is just 2. So we're going to get 2x in the brackets. And we can also subtract the 6 from both sides. So let's do that as our third line. So we're going to get 2 cos of 2x minus 88. And then we're subtracting 6 from both sides, of course. So that's going to just give us 1, right? 7 minus 6 is 1. And finally, we can still simplify this, clean it up a little bit. We can divide by 2 on both sides. We want to get rid of this 2 in front of the cos. That's no good out front, so let's do that. And that's going to leave us with cos of 2x minus 88 equals 1/2. Right, we just divided 2 by both sides. We're going to get 1/2 on the right. 2 cancels here on the left. And this is really... this is as much as we can simplify for now, so I'm just going to write therefore cos of 2x minus 88 equals 1/2, okay? Now, here's the key step really when given any equation that involves, trig equation that involves compression or shift, any kind of shift. And again, think of the graph. If you have just a basic, let's just draw a basic, I don't know what this graph looks like off the top of my head, but let's just draw sketch y equals cos of theta, right? And it's going to look something like this, isn't it? Something like that, right? And it's just going to go up and down and up and down, right? It's a basic sinusoid. And so by compression and shift, we mean that, for example, this is not how the graph for this equation is going to look like, but for example, we could say as a compression, say it's going to be, start up here and it's going to be markedly more steep, right? And it's also, so markedly more steep, so there's our compression, and then say it's shifted, so say instead it starts, say it's shifted like this way, or it could be shifted left or right, it doesn't really matter, right? So that's basically what we're dealing with that's what I mean when I say that there's compression and shift. So let's border this off. So here comes the part where we need to essentially manipulate this interval in order to catch all of the values of this in the solution of this the solutions of this equation. And by that I mean that you can essentially replace whatever in this brackets. This could be 8x minus 2 or minus x plus 60. It doesn't matter. Whatever in these brackets, you can replace it by some variable, and so that the equation essentially reduces to the type that you've solved, that to the more basic type that we solved in the first video. And maybe to make that more clear, what I would do in this case is I would say and I always use large big X prime. So we're going to say let big X prime equal 2x minus 88. So all of this stuff in the brackets, we're letting this equal big X prime. And by doing that, what we can say basically is that, so in this case, we're going to have cos big X prime equals 1/2, right? But by doing that, we can say logically as big X prime equals 2x minus 88. And I don't normally write all this out. I'm just trying to explain the logic. We can say then as theta is greater than 0. Here, sorry, I'll write that more neatly. As theta is greater than 0 and less than or equal to 360 degrees, it follows that big X prime, now this is the part where we manipulate the interval, big X prime, well, there's a coefficient 2, right, in front of this x. So we need to multiply by 2 on both sides. So we're going to say big X prime is greater than not, right, original interval, times 2. And it's less than or equal to 360 degrees, once again, times by 2. Okay, so I think that's maybe what should be emphasized as the key step. You want to basically replace your theta in the interval with your variable. It could be anything, a smiley face, it doesn't matter. This is just an arbitrary symbol, okay? I just use big X prime. And then you're going to want to essentially readjust that interval for big X prime. So we need to multiply by 2 because there's a coefficient 2. We need to multiply both sides of the interval for that by 2. What's this come out to be? Well, we get, 2 times 0 is just 0. So we get big X prime is still greater than 0, but it's less than or equal to, well, what's 360 times 2? That's going to give us 720. But we also have a negative 88, minus 88 in the brackets, right? So we need to subtract 88 from both sides. So let's just do that. To save space, I'll just write it like this on the same line, the second line. So we go minus 88. Now let's readjust. Well, 0 minus 88, that's just going to be negative 88, right? So we get big X prime is greater now than negative 88. And it's going to be less than or equal to 720 minus 88 is 632. 632. Okay, this is our new interval. So I'll just write a note. Interval for big X prime. Now we can box this off. We're pretty much almost done at this point. It's all very simple from here. The key is to manipulate the interval, really. Because now all we need to do, and really when one gets used to this, you don't have to write this many lines. You'll be able to figure this out much quicker and save a lot of space. But nevertheless, so we've got our new interval. I'm just going to scroll down a little bit to get some room down here. We've got our new interval. Now we can basically start working toward our solution. So let's write this. We know let's just write it again. Let x prime equal 2x minus 88, right? I'm just writing it again to just show a continuation of the logic. Then we get, so then we could just say it follows cos of big X prime equals 1/2, right? Because we're just letting the stuff in the brackets equal big X prime. So now we have cos big X equals 1/2. This is what I meant at the start of the video, that it simplifies to very similar to the form as at the outset of the video that I compared with, of cos theta equals 1/2, for example. This is so simple to solve, right? This is a much simpler form to solve than if we just kept it like this. And we've adjusted the variable accordingly, or the interval accordingly. And so what is cos big X? Well, this is just going to be, of course, big X prime is going to equal the arc cos of 1/2, and we know that arc cos of 1/2 is just going to be 60 degrees, right? Cos 60 degrees. So this is our first solution. And so let's just box that off to save some space and to just make things tidy. So that's our first solution. So what does that give us? Actually, let me write it this way. What does that mean for us? Well, let's just picture a phasor. Our first solution is 60 degrees, right? So it's going to be somewhere in here, something like this, right? Let's call that theta, or we'll call that x prime, sorry. Let's just call that x prime. And so that's our first solution. We know also that cos is positive, right? Because it's set to equal positive 1/2. So we know all of our solutions are going to be on this side, where cos is positive, right side of the y-axis, basically, right? So essentially, we just need to go around our interval, and so in other words, just go all the way around our interval, however many times we need, until we come up with the maximum number of solutions. And so the best way to picture this, in my opinion, is just as a phasor, right? We're just going around a few revolutions. And so we know that the first solution is 60 degrees, so we can just replace that then. X prime is 60, or we'll just write it like this. So the second solution, or the other solution, is going to be x prime as well. And so going all the way around, we're going to, what you'll do, if you work through this, you'll find that you're going to get x prime equals minus 60, right? Because x prime is greater than negative 88, so we can account for a negative value going this way instead of this way. So we're going to get minus 60 as one solution. We've got 60 as another solution. And what else do we have? Well, if we go around once more, going around in the positive direction, we're going to get this vector again. So it's going to be 360 minus 60. So that's just going to be 300. And we come up here. This is 360. So we're still in our interval. And that's going to be 360 plus 60. That's going to give us this vector again for a second time. That's going to be 420. And how many more times can we go around? We can still go around, I think, once more. So we're going to come all the way back around again. That's 720. 720, is that right? Yeah, 720 minus 60 is going to give us, no, because we've got 360. And then we've got 360 plus 60. 360 plus 60 is going to give us our 420. Then we're going to go all the way back around. That's going to give us 720. And so we can say 720 plus 60 is going to be way beyond the interval for x prime. But we can do 720 minus 60. That's going to give us 660. And that's probably the only other solution that we can plug in here. And now we just have to readjust, right? Because we've manipulated the interval for x prime, so we just need to readjust. So we know that x prime equals all of this, right? 2x minus 88. So we just write that in, 2x minus 88 equals, and then all of these values that we found going around the unit circle, if you will. And so that's 660. And so all we need to do, this is just basic algebra at this point, and you're going to get all of the correct solutions for that, for this original equation up here. And so by that I mean if we just divide by 2, yeah, we can just divide by 2. Yeah, let's just divide by 2 right across. I mean, we could, yeah, let's just divide by 2. So we get x equals, what's 88? Negative 88 divided by 2. That's negative 44. Negative 60 divided by 2 is, of course, negative 30. 60 divided by 2 again is 30. 300 divided by 2 is 150. 420 divided by 2 is 210. And 660 divided by 2 is 330. Now, we want to add 44 to both sides, right? Just basic algebra. And so we're going to get our final solutions as being 1474, 150, this 44 is 194, and we have 210 plus 44, that's going to be 254, and then we have 330 plus 44, that's going to give us 374. So our original interval is only the theta is less than or equal to 360, so we can cross that off. Okay, that's beyond the interval. So these are our final solutions. These are the solutions to the equation 2 cos of 4 times x over 2 minus 22 plus 6 equals 7.